in. So welcome everyone to another Friday edition of Facilities Director Meeting. Lots of fun times we've had. We have a really fantastic agenda today, thanks to Shane. So I really appreciate all the work he did putting this together. So let's get this going. Shane, take it away.
All right, so I'd like to welcome a few experts in the HVAC industry that have been gracious enough to lend their time to be on the call today. We've got Lori, and Andrew, if you could drop in her info. We've got Lori Gilmer, an engineer working up in Santa Rosa on the call. She's also an IFMA and ASHRAE board member. I had to look it up, so I felt like I should share it. ASHRAE stands, and some of you will probably know this, but I had to look it up. American Society of Heating, Refrigerating, and Air Conditioning Engineers, and the IFMA, of course, is the International Facility Managers Association. Also like to welcome on the call, we've got Ken Felice from ESI. Ken is the Senior Project Manager there. And we've got Chase. Chase is the Service Manager. And I think you guys are from Sacramento or Santa Clara?
We're out of the Santa Clara.
Santa Clara, okay. And then I think we've got Ron and TJ hopping on the call as well. I think they're Ron from Sacramento, I know that. So thank you guys for joining us. We appreciate your time.
Sure.
This is, like we've talked, this has been a fairly hot topic on most of our calls. Even when it wasn't the topic, it's been a topic. So let's get started. Well, before we get started, feel free to mute your mic unless you have a comment or question. If you'd like to ask a question, feel free to ask the question, or if you'd like, you can drop it in the chat window and I'll read out the question for you when there's time. So let's get started to ESI and Lori, and maybe we start with Lori. Can you walk us through some of the different types of air filters and add-ons that are out there? Kind of like we've heard about UVC, we've heard about ionization. Can you walk us through what's out there and what schools should be looking at?
Sure. I'm going to drop back to maybe a little bit higher level. And Andrea, if you could put in that first slide, one of the things to keep in mind in the pandemic environment in particular is we're dealing with something that's that we've not seen before and that we're working to wrap our arms around. And so as we think about that, there was some interesting information that came out of Harvard, and I don't quite see that slide yet, so I'll just verbally walk you through some of the key points.
Looks like she's working on it there.
Okay, no problem. One of the things I think that I saw from facility managers in the very beginning of the pandemic, right around kind of March, April timeframe, was this press for answers and wanting to know desperately, what do we do? What do we do? What do we do? And the pressure to provide those answers out of the engineering community, the facility management community, the contractor community. And one thing to be mindful of in thinking about that desire for answers, we all are looking for the most perfect answers, but really what's best to do is to drop back just a little bit and understand that this is, we're going to be looking for those things, but most of the things we figure out are going to take some time. And so we need to be patient with our ability to work through those issues. The situation continues to change as our understanding grows, and it's going to take some time to develop those best approaches. This came out of the Harvard Business School for Crisis Management for Leaders, and they put in some great oversight and guidance on, again, how do you think through this and resist that pressure to jump to answers, but think through your process. So from a facility management perspective, the thing that we really can best wrap our arms around is what are the processes that we need to put in place to provide an environment that minimizes the risk as we think about that. And actually, if you want to go over, click to the fourth slide. I pulled together some kind of high level guidance, and this is largely attributed to ASHRAE on again, how to think about indoor environmental systems and what do you need to wrap your arms around. So a couple of the statements that ASHRAE has made as we think about the role of HVAC systems in the preservation of indoor air quality and minimizing risk, we're understanding that, again, as we continue to learn and figure out how's this thing transmitted, and is it going to be a risk, or is it more of a mitigation measure? It's really being thought about as an essential part of an overall strategy to maintain an appropriate indoor environment. So ASHRAE will tell you that we need to be running our systems. There is a recommendation to increase outside air if you can. There's also a recommendation to increase your filtration if you can. So when we talk about something like a MERV 4 filter versus a MERV 8 filter versus a MERV 13 filter, as the numbers go up, the ability to, the amount of stuff that you can filter out increases. But with that, you also end up picking up a lot of loss. So a MERV 8 filter, for example, is not going to pick up virus particulates, but something on order of a MERV 13 and then some will pick up those things. But with that, again, you're picking up a lot of loss in your system. So your system may or may not be able to handle those higher grade filters. There's a space constraint and a rack accommodation that you have to think through. And then there's also whether or not the motor can handle that. So some people are going ahead and moving to change their systems out to provide increased filtration. Other people don't have the ability to do that. There's not a necessarily right or wrong answer on this. If you can do it, great. But one of the things to also think about is this is part of a larger strategy. Transmission of virus through HVAC systems is not likely to be the most probable method by which things are communicated. It's more likely that virus transmission is occurring through proximity and touch. So those strategies of maintaining and reinforcing hygiene, maintaining and reinforcing proximity, distance maintenance, so 6 feet apart, wear your mask, wash your hands, don't touch your face. Those are some of our best defenses. They're really simple. And I think for some of us, they feel really, really basic, but they are some of our best defenses against transmission of virus and generally for the health of people and maintaining our health even in cold and flu season. These are good practices that help us reduce our overall transmissibility of disease and whatnot.
So Lori, when you talk about filters, I know like just at my site, and I've got, fairly new equipment. I mean, probably in the last 10 or so years. I know like I can't go to a 2-inch filter unless I have to bend these tabs to fit a bigger filter in there. Is that what you're referring to? Or are you referring more to like back pressure in the unit, that sort of thing?
Both actually. So if your filter rack does not accommodate a thicker filter, you may or may not be able to, unless you adjust your filter rack and unless you have the actual physical space to accommodate that filter, you may not be able to put it in without significant modifications to your HVAC system. Then there's also the back pressure issue. You have a certain allotment of static pressure available on your system, and your filter, as it gets dirty, loads up and eats up static pressure availability. And there's a point in time where you change that filter out. Now you have a clean filter, it's less loaded, you have a little bit less loss across that filter. So something that we're usually monitoring is, when is it time to change a dirty filter? For some of us, it's every 3 months to 6 months. For some of us, it's when that filter loading gets to a certain static pressure drop, then we change it. So we're already monitoring those things, but now if you put in a higher grade filter, you're already starting out with much more loss that's going to increase the more loaded it gets. So those are things we want to keep our eyes on. If our filter has too much static pressure drop, it can overwhelm your system's ability to move air. You could end up burning up your motor. For example, if you put too high a grade filter on that your system can't accommodate. So those are some real concerns as we think about putting filters. So there's the physical space, and then do you have enough motor horsepower to actually drive the air through and get the air to where it needs to go.
So Lori and maybe ESI, you guys from the service side can comment as well. When, I mean, I'm not an HVAC guy. So I wouldn't, and I don't have testing equipment to test the back pressure. What would you say is a good rule of thumb for for your typical facility manager to put on their PM schedule to address those filters? Would you say, this is a rule of thumb, 90 days, 60 days?
Typical is 3 months. Your typical schedule is going to be 3 months. Sometimes they go up to 6 months. And what people are often doing is doing a visual inspection, looking to see if it's loaded. If you have construction in your area and you have a lot of debris kicking up, you may actually have to change your filters sooner.
I guess that would depend if you have, like, we have a building management system, so we can shut everything down at the end of the normal day. Some systems and some schools may be having, things running around the clock or running a little bit more, and I guess that would probably impact the life of the filter as well.
Right. And the guys from ESI, I think you're muted.
Yes,
Yeah.
hello.
We most of our schools are doing on a every 3-month basis. Some geographically have changed where they're at, and we've actually gone to 2 months. Just trying to, they're in a higher, more, and they've chosen to go a little bit more frequently. Commercially, we have customers that are every 2 months and have done that ever since they built their buildings, and ones that go out to the twice a year. The twice a year, we always end up usually getting some form of a service call that generates us to end up changing the filters, as opposed to we will eliminate some of those calls by a little more frequency on the filters. And it is pretty surprising how quickly they load up, even with the activity from classrooms to classrooms. You could have a row of rooms, and one is a very active kinder room and one is a kind of sedentary third grade. In the kinder room, because they're just generating more airborne particles, we end up changing the filters faster. So common is probably every 3 months. Right now, since COVID, we've had a lot of situations where we've gone to every 2. And just a shout out to the whole group, what we're noticing, and it's a shame, but the now manufacturers of filters are actually slowly increasing their MERV 13 filter prices. And it's very slow, but since we're buying so many of them, we're seeing the volume change at day to day from 50 cents a filter. And that could be over the course of 4 days. Well, in the course of 4 days, it didn't cost them 50 more cents a filter to make it. So we are noticing some definite increases, and you're gonna see impacts financially for the cost of changing out just MERV 13 filters. And besides the fact that we're running into stock, we're still stockpiled pretty well, but some of the vendors are actually running out.
And then their prices are reflective of their limit on supply.
Yeah.
One other thing we've been seeing, so just over the past, say, 3 to 6 months, as the MERV 13 or greater, but typically MERV 13 is about all we've been able to manage with existing systems and existing horsepower ratings. As those filters have been introduced, we're now seeing the frequency needing to be replaced sooner rather than later. And I can attribute that to the tighter weave of the higher efficient filter. So it's actually capturing more, it's doing more, and then it's loading up faster. So we are seeing that happen kind of as we speak, and then we're addressing those.
But much
places.
faster than we would have seen a classroom or an environment before. I mean, we're getting to the point with some of these MERV 13s, I think we're going to end up being on 60-day changeouts. Mm-hmm. Building to building, again, commercially, that would be different, but in the schools, the frequency has really shot up. Even with minor amounts of usage in the rooms right now, we're still seeing a definite impact of the filters getting dirty faster, even at our own office where we've put them in, where we could track it more regular. So just be prepared for that on your budgets. And with the MERV 13 filters, the costs are going up and the frequency is definitely going to need to go up, or you're going to have more service calls.
Perfect. Thank you. So Lori, I wanted to go back to you. We had talked on a couple of our calls. There's kind of like seems like there's two main add-ons that facility managers can look at, and that's what the UVC or the light filters, and then there's an ionization filter. Can you talk some about that? And then maybe ESI, when she's done, maybe you guys can talk about the implications of those and what are some of the ongoing financial considerations that and preventive maintenance that these systems can need. We've talked about before, you've got to replace the light bulbs. There's an expense with that. And there's a labor expense. So, Lori, maybe could you just review those types with us? And if I missed anything, feel free to add.
Sure. Yeah, you've hit the nail on the head. UV and the needlepoint bipolar ionization filters. Those are the two kind of big technologies that we're seeing out there being regularly talked about as mitigation strategies, in addition to some of the common things that we're doing, like regular filtration. Starting with UVC light is the one that's very effective. And there's a few cautions. It's used in hospital environments pretty frequently, less so in lower grade environments, so schools, commercial offices, that sort of thing. It's being talked about as something that could be very effective, but there are a few cautionary notes to put with that. You do have to be very careful with exposure to UV light, particularly the UVC exposure to skin, exposure to eyes. So when we put that kind of system in place in a within an enclosed system, you can control it a little bit, but you do need to be very careful that during O&M checks that those systems are turned off. They also need to be cleaned and maintained in order to be effective. So they can be very effective at killing bacteria and virus populations, but again, it's only going to be what the light is shining on. So it's not going to clean the corners of everything in a filter box, for example, unless that light can shine on those surfaces. The exposure time you also have to watch, and that would be something to take a look at on the design side of things. The other thing to watch is ionization in general. Air ionization, actually I'll talk about that in a second when we get to the ionization part. So those are a couple of things to watch out on UV. On the needlepoint bipolar ionization side of things, ionization in general has been around for a long time. It's been talked about for a long time. We have little ionization, little setups you can buy for in your home, and it's promoted as being super healthy. And one of the key things to watch out for, though, with ionization is its ability to generate ozone. That is actually not a healthy solution, and we have to be very careful about ozone generating devices and being around those things. There is, and I'm looking at a quick reference. So ozone can cause irritation to lungs and can actually reduce your overall indoor air quality. ASHRAE had a publication in 2015 called the Position Document on Filtration and Air Cleaning, and they indicate in that document that ozone is harmful for health and exposure to ozone, and it creates risk for a variety of symptoms and diseases associated with respiratory tract. Ozone emission is thus undesirable. So again, be really, really careful about devices that ionize and in that process produce ozone. With that said, the needlepoint bipolar ionization, it is a mouthful, that technology, the claim of it right now is that it doesn't generate ozone, and they cite a couple of resources. They cite UL 867 and UL 2998 as their certification. UL 867 is the standard for safety for electrostatic air cleaners, and that addresses the safety of portable and fixed electrostatic air cleaning equipment. UL 2998 is the environmental claim validation procedure for zero ozone emissions for air cleaners. So according to those two things, they're saying we're not generating ozone, at least in a detectable degree that would result in these concerns that ASHRAE has brought forth. In general, what the technology promises is that it will reduce contaminants in the air, reduce pathogens in the airstream, improve efficiency, and the efficiency is related to a cleaner coil, which is going to give you better heat transfer. They also talk about it allowing for reduction in outside air, but I'll do a little caveat on that. We'd want to be really careful with reducing outside air right now. The CDC is recommending, and ASHRAE is also recommending, that we actually add more outside air if your system can handle that. Outside air is expensive to condition, both heating and cooling. Your system is also generally not sized in school facilities, not sized to handle lots and lots of outside air. There's a limit where you will run out of your ability to actually condition that outside air. So increasing the outside air, wonderful. Just don't strip the ability of your system to heat and cool that air. So that's one thing we want to watch out for, and not a benefit you'd be looking for in adding this technology at this time. And then they also talk about reducing energy consumption, which is again related to decreasing outside air, which again, we don't want to go down that path. So those sound like good promises. In general, I've got a few concerns related to that, and it really has more to do with the lack of independent testing. I've been digging into this and looking for more resources that show the results and the benefits of the technology outside of those who manufacture it and sell it. The manufacturers and the sellers, they're going to have their position, but I'd like to see the independent testing, and I'm not seeing enough of that to make me feel comfortable about getting behind it wholesale. I think it's an interesting technology to look at, and if it meets what's promised, that's great. But I'd like to see a little more study. It also, worthy of note, it does not eliminate the need for air filtration. So if you looked at it from an IAQ standpoint, you would look at the addition of this as a large part of a larger strategy to improve your overall indoor air quality. So we're not getting rid of filters. We would be adding this on as one more thing that we can do to reduce risk in our overall IAQ management strategy. I will over to the other side.
So Ken and Chase, do you guys, I think you've installed something on one of your offices. Can you talk a little bit about that, and then maybe kind of go into the long-term maintenance things that folks like me have to consider when you're looking at these options?
Yeah, so to Lori's regarding the independent testing of ionization systems, I had the exact same feeling that, the manufacturer says it does this, and, I'm not comfortable talking to my client base when it may be smoke and mirrors. So I like to have a pretty strong understanding of something that I may or may not be selling. So we partnered with an environmental testing firm, and I had one of my vendors that represents the GPS product line, which is Global Plasma Solutions. I had them sponsor a couple of ionization systems sized for a couple of machines I have here in my office. We installed those machines or those devices in our machines. We hosted a pre-test of the 2 zones that were affected. We did about a 2-hour sampling, if I remember right. And then we had about a 12-hour runtime with ionization systems on. And then we did a post-test. And that post-test followed the same protocol. And just so you understand, I'm no scientist. I'm an HVAC guy wanting to understand that what the manufacturer is saying it does, it does. So this was my approach to that. So after the post-testing, we got the results from the testing agency. And in my opinion, it was very in-depth, but very hard to simply read. So what I gathered out of it was a significant move of the needle in the right direction. And then the testing firm offered to kind of put it together in a summary form, so to speak. And then once it was summarized, it was much easier to kind of associate. So just as an example, if the pre-test measuring 10 different VOCs, and the different values were, one was 400 and one was 200 and one was 100 and on down the line, the post-test reflected, I'm just going to approximate, but like a 50% reduction in those VOCs. There were a couple of things that maybe didn't move very much. There were a couple of things that moved drastically. But overall, I felt that the needle moved and in the right direction. And that in itself gave me the ability to at least talk about it in a more logical way. It's not just the manufacturer said this. I actually have a document that shows what was looked at, what was tested. I know the amount of runtime on the ionization systems between their two test points. And that just gave me kind of a feeling of comfort when it comes to actually talking about it. So hopefully, I don't know if that is anything along the lines, Lori, that you were looking for. I do have, results to that. Again, this is not a controlled environment. It's literally my office space. And we targeted 2 different zones that have different sized equipment. So let's just say a 7 to 10 ton package unit and then a 3 to 5 ton package unit. And we installed per the manufacturer's, recommended application. We actually took some photos and documented how it was installed. And then again, did the performance test. And I was pretty impressed with the results.
Yeah, we actually, and anecdotal about it, it actually did pick up that we do have a pond in the middle of our office from way back when it was built. And it actually did pick up an increase in some mold coming on, because we were actually in the process of treating the pond and it was having chlorine and work done to it. So that the airside air quality tests that were being done did pick up in an increased environment towards not healthy, but it was something we were doing in our space that caused that. So we were really confident with the results that we saw here from our own testing that was done, that we saw a 50% improvement across the board in general for all of the sampling that was done by the company.
That's great. So I see a question in the chat. Looks like it's addressed to Lori from Dave Marcus, who I think in his last photo, he was out on the golf course somewhere. So he's taking to prompt the question. But he's saying, where does purification fit into all this? And who needs what and at what price levels?
Air purification, I assume you're talking about. What we're talking about in overall, from a purification, that's kind of a interesting word to use with air systems. In general, what we're trying to accomplish with the treatment of air in systems is the reduction of stuff in the airstream, and it typically started kind of early systems started with more let's get the dirt, the dust, the pollen, the bugs, anything like that out. And so what you'll typically see on an HVAC system are ways to screen out the big stuff like bird screen and that sort of thing, keeping out birds and bugs. And then you see filters that help keep out dust and pollens and things. And in more critical environments, we see more intensive filtration systems going all the way up to HEPAs and ULPAs. And in those systems, we're just trying to reduce that content that's allowed to swirl around and be distributed around our spaces. So as we've walked through our ability to treat air, and you think through filtration, the additional technologies that have come on board, like UV and like the needlepoint bipolar ionization, those are things that are additional strategies at helping to knock out certain elements. UV light isn't going to do anything for dust, but it will do something for your microbial population. The same will be true for the needlepoint bipolar, although that's also dealing with VOC, so it's not going to It's not going to deal with your dust. It'll deal with other things. So as we think about the constituents that make up our air, these strategies are multi-layered that help us reduce the amount of stuff that that does get distributed around our facilities. In terms of air quality and what we're looking for there, and I don't, ESI, you may have the reference offhand. I was thinking through what the allowable limits are for VOCs and other contaminants. I think it's ASHRAE Standard 62 that has that detailed in it. It certainly talks about outside air and the amount of CO2 and other gases that can be in the air. We're looking to maintain air quality within a tolerance level and not go over particular limits for different kind of constituents that are in the air. So we're looking at particulates. We're looking at the makeup of outside air. How much CO2 do you have, as well as other VOCs. That guidance is typically coming from a standard like ASHRAE Standard 62. So again, as we look at air purification, I'd rather think of air quality and looking at ways that we can improve our indoor air quality, of which filtration and UV and whatnot are part of that total strategy.
Great, great. I see another question from Felicia. You talk about, and this is to ESI or to Lori, whichever is most appropriate. Can you talk about air scrubbers that can be added to an existing system?
ESI, do you guys want to take that first?
Sure. So we haven't seen a lot in the environments that we're talking about, school settings and such, where we would go to such an elaborate system as what would be an air scrubber. And most times in our experience, it's used when we're discharging air to the common environment, to the outdoors. There's lots of guidelines and regulations that are driving the companies that are creating the pollutants on how clean of air they're to discharge back. The smaller settings and things that people talk about, air scrubbers, again, goes with that kind of buzz line of the purification. It's we're not really scrubbing the air in the environments we're talking with the schools. It's the filtration of the particulate count. And then further, as Lori said, into the levels of the VOCs in the space. There's no really cost-effective way of doing that sampling and testing on a constant basis. Like the company that we work with, they've got really good package prices to come in and do samplings in schools, and they do the COVID surface test and all those sorts of things. But as an ongoing test, there's no really good way to determine the quality of the air, not an inexpensive way to kind of keep a status on the quality there besides CO2 sensors. So air scrubbers and air purification, like Lori said, they're kind of more terms that are being used out of context for what we're really trying to do with the filtration, and then further trying to get down to the virus level and bacteria level.
Yeah, I'll say to Ken's point, I've had clients ask for scrubbers, and then I actually had one of my equipment suppliers tell me they had air scrubbers, and what they had was a portable HEPA filtration system, which I guess you could call that an air scrubber. I call it a HEPA filter. But at any rate, what Ken is referring to with the scrubber systems in the more industrial term, it is exactly scrubbing, chemicals out of the air to be discharged into the atmosphere legally, and not so much for, the human level of the application.
Mm-hmm. Yeah, agreed. And I think building on to that, one thing to also continue to remember is when we talk about what is going to be most effective for our interior environments, it's really easy to run straight over to all of the new technologies that we think we need to strap on to make sure that things are super, super safe. And one thing to remember in the whole, from a risk and mitigation strategy, is some of the most important things you can do are really more related to individual interaction. It's that proximity and hygiene element. the managing the indoor air quality is certainly something we always need to be paying attention to, but it doesn't wholly on its own take care of the pandemic issue, pandemic related issues that we're dealing with. It is something that we need to address, but it is not the totality of the response that we need to make sure we're backing up.
You know, what we've noticed going through this is one of the things that often gets missed or during budget times not provided enough funding source is for the indoor air quality. And myself, the way that I came through the trades and was actually working on your guys' side of the table for San Jose Unified and UC Santa Cruz, certain costs like that towards the maintenance and the ongoing care get missed. And what the pandemic has brought is an attention to indoor air quality, which is great. And I think it really needs to be done, and there's huge benefits, but there's still some real common sense approach that we can make the inside of a classroom, the inside of a building, as clean as we possibly can for particulate matter, and try to take it back up to a higher level with bacteria and viral matter. But the minute that you go outside, or the minute that these students go back to their homes, go back to the cars with mom and dad, it's still there. And they're now into a worse environment than they were in the classroom, meaning we can only give them really good quality air to breathe in that little box. And these teachers that are going forward, and the teachers unions that we're hearing from, and they're wanting doors and windows left open, and these things are all completely counterproductive to putting in higher quality filters. You're going to load them up faster. You're going to change your filters a lot more. You know, there's certain common sense approach. And right now, and it will change, but right now with the decreased amount, the normal size classroom, and the amount of allowable students with ed code, and the amount of students they're saying they're in the classroom right now, technically, if schools came back with a partial or a hybrid where they only have 15 students instead of 30, you don't necessarily need to increase your outside air now, because you've actually doubled the amount of outside air because you've decreased the people in the occupants in half. When that room goes to full and we get a green light and everybody's back, you're going to see a lot more fresh air that's being needed, and expensive fresh air to heat and cool it. And you're going to see a massive impact on these higher quality of filters.
Mm-hmm.
Right now, a little kind of holding pattern till we all get that release date when the students come back. That's when you need to be prepared to have the systems going. We've had some schools that have jumped to the head of the pack and have cleaned everything and got all the outside air ready, and the buildings are all set up for 30%, 30 student occupancy, and we're just in a holding pattern. And we have other schools that are doing absolutely nothing until they get a green light to send everybody back. And that's going to be kind of chaotic, because some of these larger school districts, you can't move that fast to check outside air systems that haven't been maintained or serviced for the past 15 years possibly, because even the basic PM programs that the schools can afford don't always allow for those types of checks to be made on a regular basis. So there's just a little common sense that we need to keep with all of this. We don't need the most expensive fancy equipment when we look at the larger picture like that. And to move quickly into that right now, when we don't even know when the schools are going to open back up and to what level, the best you can do is like the MERV 13s, really check the outside air that we have that's actually functioning, what we have that's capable, and that it's clean, and then wait to see what some of the next guidelines come up at when we do get full occupancy back.
Yeah, that's perfect. I mean, just anecdotally from my school, I've seen some teachers come back by themselves in a 900 square foot classroom, and they open every window. They, most of our classrooms have 2 doors, so they open both the doors. If you guys have been around the Bay Area earlier in the week, it was 100+ degrees, and so they're complaining to me that hey, I'm in here with my mask on by myself and I'm sweating and the air conditioning can't keep up with it. And it's just kind of, to Lori's point, it's like when it's 105 outside and, our economizers are as wide open as they can be. The system just can't cool the fresh air coming in. It can't cool it that much. But you guys started to talk about indoor air quality, and it looks like Adam was posed a question about is there a cost-effective way to monitor indoor air quality? And he's saying not so much for COVID, but for some of us that are in the fire areas, like for smoke and ash, and just indoor air quality in general.
There are, if you have a newer EMS system, one that's probably genre of the past 5 to 8 years, you probably have it capable where you can put in air quality monitors. Again, not COVID related. It's not looking at that level. It's looking more at the particulate level. We do have a school district here that is in the mountains that literally gets affected all the time when these fires come in. They're right now looking into a system to be able to, I should say before the pandemic, we're looking into a system that they could globally shut down all their outside air when the fires hit and the smoke levels rise. But that's counterproductive to everything we need to do towards COVID and the pandemic. There's still more 2 years from now, hopefully, and we're not in this anymore. What do they do when there's a wood fire in the hills and they have students still in class and the fire is still far enough away to where they don't evacuate? They're closing down the outside air for a short period of time. Having the better filters is a help for them, or the parents just keep all the kids home and then nobody goes to school. So there are, with an EMS system, effective ways to put in monitors. It's just what you do with that information after. The minute, I know from my time with the schools, the minute that you find out something, that's the problem. You need to kind of act upon it. You can't just always put it to a back burner. And if you start air monitoring and you start seeing problems and we start seeing where levels are out of spec to where they should be for an indoor environment, that school, whoever picked up that monitoring, now needs to act. And so there is technology out there that can do that.
So when you say EMS, you're talking about an energy management system or a building system.
Your building automation system or your energy management system, in any form of communicating with equipment that you have, we can typically integrate. I'm not going to say it's an indoor air quality sensor, but it basically is that, where we're counting parts per million of whatever particulate it's calibrated to. And it can report to the system. It can make a calculation based on how the algorithm's put together. It can drive an outside air damp or open, or drive an operable window, or whatever the design may be. That technology is there, and we have it implemented at several sites. And I'm sure Lori's seeing it, being designed into systems as Title 24 levels, increase over time.
So sorry, Lori, go ahead. Didn't mean to cut you off.
I think overall it speaks to, I think a point that that was made a minute ago was, it speaks to the overall need to understand your systems and manage them according to the circumstances that you're dealing with. And it's exactly right to say that, coronavirus, we want more outside air. And as a just quick side note, there was a question about the outside air and what are we referring to. When we talk about outside air for HVAC systems, typically we're talking about what comes through your outside air duct into your system. So it's part of the conditioned system, not necessarily the outside air that we bring in through an open window. But in any case, as we think about outside air during the fires, where we have ash and smoke coming in, we need to also minimize that, and that's going to lit up our filters as well. So we're trying to make good decisions on behalf of our schools and the people in those facilities to minimize the impacts. And it may be that the fire impact overrides coronavirus impact for the moment. because bringing in outside air, while it's great, the idea is that the outside air is a little bit better than the circulated air that we have inside. But during a fire, that may not be true. And so all of us on the facility management side are needing to look at the total equation and not make binary decisions like it's coronavirus, therefore we're going to open up all the windows and we're going to open up our HVAC systems to 100% outside air. It just might not make sense during a fire. So we have to be thinking about the impacts to the interior environment as we manage the various strategies and systems under our care.
Great, great. So just to back up, because I've got a couple of questions on, guys, when you were referring to EMS and BMS, energy management system, building management system, as you guys know, I use IntelliWeb, which I think is a Delta Controls product. You're talking about a system that interfaces with all of your heating and air units. You can set up schedules. Just to clarify what these things do, they show your energy use.
Yeah, the EMS or the BMS would be more of a centralized control system versus a school that still may be taken care of and maintained by schedules with a time clock. So that's what I'm saying. Something of the past 8 to more recent in time backnet capabilities, which allows all different types of componentry and equipment controllers to communicate back and forth with each other. So if you have a more modern system, it's going to be much more easily added on to for the indoor air quality, particulate count, CO2 monitoring, those sorts of things. An older system beyond that, and you don't have an EMS, yeah, it's a complete site-wide, upgrade the entire to an energy management system that allows these capabilities. That's where it gets expensive. But on an existing system, it's not that bad to add some additional sensors and things. It's just, what do you do with that data once it's given back to the school district?
Well, I'm here to testify. It's well worth it. I need, from you guys, I need Ron Hillman's support quite a bit on the backnet part, but the user interface, I'm sure the return, the ROI on the expenses is not very far out, because from my standpoint, with the click of a button from the comfort of my couch, I can turn the entire school off schedule, no air conditioning, no fans, no lights, no nothing. I can turn it all off and I can have a schedule. Whereas, some of the schools that I've been at before didn't have these. If you've got a teacher that, came in on a Saturday and she was particularly hot and she cranked her thermostat down to 68 and then she left for the weekend, well, that unit's going to sit there and run until it gets to 68. And it's probably never going to get to 68, but it's going to sit there and run and run and run and run. And you're going to pay for all that electricity. And when you've got the building management system, you can control that. You can set the override so they can override it on a Saturday, but only for, I think our system is like 2 hours.
On the bigger scale of that and the controls and the ad, at such a school district that I worked at, had the 50 sites. When it came time to look at their energy management system, should it be upgraded, should it not? We ended up having a design firm, sorry, Lori, somebody besides yourself.
No worries.
2 separate commissioning agents give us some factors as to how far do we replace the EMS system? Do we turn it back to really simple and just turn equipment on and off, or do we have some of these other features? And by the sheer fact alone of just adding the CO2 sensors, which controls the amount of outside air into the classroom when it's needed, and only when it's needed, not when it's not when the need for the lower CO2 levels is there, it closes the damper. That piece, that component alone had an energy savings at those of HVAC energy savings. I think it was about 27%. So for that amount, so under 30% of the load they were saying is by units at these several school sites that we were looking at, were running with outside air that had no control over it and was a fixed damper amount of air. By being able to control and close those dampers down, we decreased the energy substantially, and it made sense, and it did have a better ROI. And we went forward with a complete upgrade to the entire district of giving CO2 and giving those types of levels of controls for those units. So it's available. It does make a ton of sense when you're upgrading, and then it does give you the features of the CO2 and the air station kind of sensing for just the quality of the air, and you can act accordingly. Our one district, which they're kind of kicking themselves, and they are in the way and really in the path of the fires right now, put on a much lesser EMS system, and it's very popular right now. They now don't have the global control over their outside air dampers that they want. And they're now running into having to close down the schools because of the indoor air quality for just those single individual teachers that are sitting in a room by themselves. But they just can't get that outside air down. And so now they sent the teachers home that they told them they needed to teach out of the classrooms. Now they're sending them all back home because of the fire. So it's caused massive confusion. Now they're having to flip back to different technologies. And so by making kind of a decision that it was more cost effective and they saw it, but now they can't do the more global work that they want to do. And now they're struggling and paying the price. And so they actually took, I think, today off and possibly Monday to regroup and see if the teachers are going to be able to come back with the fires, or they're going to have to do complete distant now and change their whole way of starting the school year again.
Yeah, I mean, I could tell you with, as you guys know, with IntelliWeb, again, from the comfort of my couch, I could set the economizers to 0 during the smoky time, still have a little AC running.
Yep.
Looks like we got a question, though, maybe to you guys and to Lori. Is there any conclusive proof that the COVID-19 has been transmitted through a ducted heating and air system? Has there been any tests to say, yes, the virus can go that way, or one way or the other? Have you guys heard of anything?
The case study that is has been most reported was related to a what I would describe as a window shaker type unit, where the virus wasn't transmitted by the HVAC system, by the little unit, the air conditioning unit. It was more of an airflow issue. So the airflow was blowing across people in a restaurant and was providing a better air path for transmission and communication within a conditioned space. So it had more to do with the in-space airflow, less to do with the HVAC system being the actual distribution path. The things that I've been reading have related more to the concern that it could be a transmission path, but also speaking to the lower likelihood that it is the main way that that virus is being transmitted. So it's not being ruled out, but it's also not being concentrated on as a primary source.
It's the way we've been discussing it with some of our customers. Somebody who may be infected comes into a closed environment, coughs, sneezes, or whatever, off gases the virus. Then you're asking, what you're saying is that virus is now getting drawn through the air into, which is not normally a very strong return airstream because it's distributed across multiple areas for your return system. You're asking that virus to then be drawn up into the ductwork, bounce through the ductwork, through a filter, through a coil that's either heating or cooling, through a heat exchanger if you have a gas system, then delivered back down the supply duct system and dropped into a room or a room next door. And that virus is still intact, and that virus still has the potential to get somebody sick. So it's a lot to ask. The same to think that it would be able to be used as a thoroughfare for the virus. It is more likely, like the study she's referring to, is the airstream, that if somebody coughs behind you and behind that person there happens to be a supply air vent that had enough force to drive it past the 6-foot requirement, yes, you're more likely going to catch that virus from somebody because it's actually helping their sneeze project further into the room because it's pushing it along. I think there we do have to be aware of that. And there, anytime you walk past a vent, supply vent, that you actually hear the air coming from it, that has a lot of velocity to it. So that vent would have the ability to help push something forward, whether it be dust, particulate, possibly water droplets, they're saying, that are the contamination level of the COVID. Yeah, it would have more of a sense to blow it towards the next person in the room.
So guys, oh, go ahead, Lori, sorry.
It then becomes the argument for why it's starting to defend then why restaurants are closed and why people are eating outside, and why it's recommended to wear a mask, why you should be careful about proximity, why you should wash your hands. So that, again, likelihood low. I agree. It is low that it is being distributed through ductwork and sending itself all over the building. That's low likelihood. In the realm of all possibilities, sure, might be, but it's much more likely that it's being transmitted by these other means, which puts the focus then on getting people to consistently adjust their behavior in accordance with CDC requirements.
So I think we've got one last question. We're about out of time. I see, does humidity or lack of humidity have anything to do with transmitting the virus? And is there any support or reasoning that we should crank the temperatures up in our classrooms, crank the temperatures down in our classrooms? Is there any support for that? Any thoughts on that?
Yeah, there's actually a CDC tool that you can go to where you can change temperature and you can change humidity, and it will calculate transmissibility, I guess we'll call it. Generally speaking, there's a guidance out there, and I think this is posted on the CDC site, about humidity targets that we'd like to see, as well as thermal targets that we'd like to see. What you'll see is the humidity. We want to keep the humidity at or below 65%. And that has more to do with a mold creation environment. Above that 65%, you're going to have more risk of mold growing. You just have a wet environment. It's also not very comfortable, but you risk a different IAQ issue. The guidance right now is to keep it, I think it's between 30% and 65% relative humidity, if you can. In California, we don't tend to see a lot of humidification systems. That tends to just not be a problem for our indoor environments. The concern with drier air and the virus has to do with, and I am not an epidemiologist or specializing in virus, but from what I've read, it has more to do with the droplet transfer. So when the virus is contained in droplets, and it lands on surfaces, or it's entrained in the air, and someone sneezes and off it goes. It can land on a surface, it can hit a person, whatever. When the air is more humid, those droplets don't evaporate as quickly. And so the virus can land a little more quickly and be less distributable, so to speak. When the air is really, really dry, apparently it can go into more of a desiccated kind of format and be a little more transmittable when it's very, very dry. That one surprised me a little bit, but that seems to be the way this thing works. So so it's a little more transmissible at extraordinarily dry conditions compared to that midpoint area condition. Again, the guidance has been that the temperature requirements, if you can keep within the ASHRAE standard 55 realm for thermal comfort, and you can maintain humidities in that mid-range, that is a good space to be. These are not guarantees. It is a good target, though, to stay in, and generally that's where people are comfortable.
Great. Well, Lori, guys from ESI, I just want to be respectful of everybody's time. We usually schedule these things from 11 to 12, so if anybody needs to hop off, feel free. Lori and ESI, if you want to hang around, there may be a few stragglers with some questions, but
One thing I want to mention, and Andrea, if you could put it up, there were a couple of slides that I put together on resources available through IFMA. IFMA has a really good pandemic page. It's on the main page. There's a set of resources available, and one of them is the pandemic manual that is free and available for people to download. It doesn't deal with just HVAC. It deals with the totality of facility management and what we need to be thinking about. So to the extent that that may be helpful to you, please feel free to download that. That website is a good resource. It represents an effort by the facility management community to pull together resources that we believed would be helpful and appropriate. So it'd be on ifma.org.
So Andrea, that's ASHRAE. That was the link I gave.
ASHRAE has really good resources as well, and ASHRAE's got some very good statements. The pandemic manual from IFMA is going to be on the ifma.org website. And if you scroll down, yeah, right in there, you see that IFMA Coronavirus Essentials. And the very last one, that blue, the pandemic manual, that's where you can click. I think you have to put in a little bit of information about who you are, but you can download that document. IFMA also has a framework for thinking through a strategic plan. So again, to the extent that that may be helpful to you, please feel free to download that and use it.
Great. Well, thank you guys. Do we have any last minute questions? It looks like Andrea's dropped the ASHRAE info. I suspect she'll drop the IFMA info shortly. Andrea, can you remind me what our next Friday topic is? Are we back to health screening, work watch next Friday? I forget.
Let me check real quick. Let's see.
Sorry, didn't mean to put you on the spot.
That's okay. Hold on just one second. Sorry, I have a lot of screens open. Let's see, hang on.
Well, I know one of our upcoming, while you're looking for that, one of our either next Friday or the Friday after is the folks from Work Watch that are going to introduce a QR code system scanning. That a lot of us, we've created these great plans for cleaning our schools and cleaning our bathrooms and increased, effort on touch points and things like that. But we're getting a lot of feedback from folks that are saying, how do we know that your crew's really doing it? It's great on paper, but how do they really know? So this Work Watch system that we've featured on this Friday call a couple of times for the health screening part. It also has a component where produces these QR codes. You print these little QR codes and you put them, let's say, in a classroom, in a bathroom, and your custodial staff with a simple app on their smart device would scan in and scan out, and there's your proof that the classroom got cleaned, or there's the proof that the bathroom got cleaned, or whatever it happens to be. I mean, you can have a QR code for everything, and it really gives you a big source. Really gives you a lot of data to support your facilities team. You've got good checks and balances. If your team is, if they're checking into a classroom and 30 seconds later they're checking out, well, there might be, that might be a coachable moment. But if they're in there, for 15 or 20 minutes, that's probably a little more what you're expecting. So that gives you that data. So if you've got any teachers that are maybe in the high risk, older folks, or lung issues that are maybe a little more concerned about it, you can definitely share that proof with them. So is that for next Friday, Andrea, or is that Friday after?
Next Friday is HVAC.
Oh, okay.
That's what we have on the schedule, at least.
Okay. All right, guys. Well, any last minute questions while we still got Lori and the guys from ESI on the call?
Hey, Shane, just going to mention, so our Sacramento office, TJ and Ron, I think they're having a microphone problem. But I believe Ron left a download in the chat box that would most likely have some of our information and potentially the pre and post testing we did with the GPS product for the ionization. If Lori might want to grab that and just take a look at that.
So Andrea, I think I forwarded that to you. Can you drop, or did you already drop it maybe?
I think I did. If you check in the chat, it should be there. If that doesn't look like the right thing, let me know.
So Helen from Notre Dame, I see you're unmuted. Did you have a question? Or are you still on the call?
No, good meeting. I just enjoyed this meeting. Very informative. Thank you.
Great, great. Thanks for being on the call. All right, guys. Well, Lori, guys from ESI, thanks for your time. We appreciate everybody being here today and lending us your expertise.
Happy to help.
Thanks
All
for
right.
having us.
Let us
Thank
know
you,
your
everyone.
Thank you. Have a good weekend.
topic is